Jeremy Cook here for Cooked Audio. As much as I love the MIDI protocol, implementing it properly does take some work. You need 2 resistors, a diode, an opto isolator, and the DIN connector itself. Rather than breadboard up something every time I went to work with it, I decided to make my own simple MIDI input adapter. In this video, I'll outline how I made it, try out another off-the-shelf adapter for the Uno, and even to get MIDI working with the Arduino Opta. So let's see how I made it. We'll get into the actual build shortly, but first I wanted to do a quick intro into the MIDI spec. The hardware is set up in such a way that each device is electrically isolated from each other, using light to pass signals along via an opto isolator. My design implements this circuit. There's also an optional pass-through specification which can send signals along to the next device. We'll see one in action later. Outputs use specified resistors that can be set up for either 5 volts or 3.3 volts. The spec is just 6 pages long, which is refreshingly digestible. I'll put a link to where you can find it in the description. With the MIDI spec in mind, I designed my PCB in KiCad, first making the proper connections in the schematic editor, then laying them out in the PCB editor. Since my recent designs have involved mostly surface mount devices, using through-hole components in this board feels like a bit of a step back. On the other hand, this should allow for easy component swaps when needed. With the design finished, I plotted the results, ordered my PCBs, and a week or so later, these little green beauties arrived at my door. Since this is the Cooked Audio YouTube channel, I should note that the desiccant pack that arrived with it is not salt or another condiment. While the design ultimately worked, the resistor that I used here was physically way too large. However, since I'm using through-hole technology and it was the correct 220 ohm resistance value, this wasn't a problem, though I did have to swap out the other one for a 330 ohm resistor. I also installed the PC917 opto isolator backwards, which was an issue. With components soldered on correctly, I installed the SimpleSynth program from the Arduino MIDI library onto an Arduino Uno. The MIDI adapter plugs directly into the Uno's RX pin along with 5 volts and ground. This needs to be connected after programming as it will interfere with other serial communications. A small speaker was connected to pin 10 and ground, and the MIDI input was connected to my 1-inch MIDI controller, which I believe to be the world's smallest such device. With connections made, the Arduino Uno synth belted out tunes via the controller's 4 button inputs. I then tried the same thing with a buzzer, which sounds similar, but a bit worse. For my second MIDI dish, I decided to use an off-the-shelf MIDI adapter. The good thing is that it includes a MIDI input, MIDI output, and even a pass-through port as mentioned in the spec. The bad thing about this adapter is that I couldn't find any documentation on its pinout, so I had to ring everything out with a multimeter. I'd argue that my adapter is more versatile as it's not Uno form factor specific, and of course it's more compact, but there are certainly projects where either would work well. After soldering the female headers in, I loaded the same MIDI synth program as before, and it worked. Conveniently, it has a switch to turn MIDI signals on and off so that it doesn't interfere with standard serial data transmission. You just have to ensure that it's in the right position for either task. I also tried out the MIDI pass-through, setting up a second Arduino Uno as a synth, while the off-the-shelf MIDI adapter Uno was programmed to illuminate LEDs based on the note received. MIDI use with an Arduino Uno is interesting, but it's been done before. The reason I started down this road to begin with is that I wanted to use a MIDI input with the Arduino Opta per a suggestion on a previous musical project. My original thought was to use a digital input pin with the appropriate resistors for the Opto isolator. However, it seems that software serial is not available on these devices. What I found out, however, is that behind the aux tab are connections for serial input and output, as well as 3.3 volts, 5 volts ground, and even I2C. All I had to do was obtain the appropriate board edge connector and cook up yet another adapter. So it was off to play my favorite video game, KiCad. With the Opta adapter design done, I ordered my PCB, which again arrived in a week or so. The board and card edge connector are keyed, so inserting upside down is impossible, or at least very difficult. I soldered female headers onto my PCB for easy jumper insertion and tested the serial output on an oscilloscope. As a significant bonus, the adapter also allows access to the Opta's I2C pins, which I tested via a generic SSD1306 LED display. I stuck to 3.3 volts for power and I/O so as not to overload the processor. I attached my custom MIDI adapter to the new Opta adapter via screw terminals and was able to control it using my 1-inch MIDI device. I tested Opta control by blinking its onboard LEDs and by triggering the built-in solenoids, but one could see this PLC used in a variety of other different ways, perhaps as a percussion controller. We've seen here that there are a variety of ways to control an Arduino with the MIDI protocol. The circuit is simple enough to lay out on a breadboard, but if you have a custom adapter, that's even better. This project is partially background for a robotic drum machine that I'm working on that I'm really excited about. So I hope you'll subscribe and check back to see what comes next. Thanks so much for watching. This is Jeremy Cook for Cooked Audio, signing off. I'm really excited about. So, we've seen here that there are a variety